Okay, we are moving on to our last section, 1.6, limits at infinity, which means we'll be looking at having a test towards the end of next week. We're going to do a little different in formatting for the test, so I'll tell you more about that later on. But I agree, when a lot of your feedback, you didn't like switching back and forth. I was grading it. I didn't like switching back and forth. So I'm going to try and give you one format. We'll skip the Google Forms. We'll just do something else for now. And then hopefully when things get back to normal, we can just take normal tests in a classroom and we'll try to work our way towards that. All right, so in this section, first we're going to look at definition of horizontal asymptote. So in Algebra 2, when you do horizontal asymptotes, you essentially look at degree. So you think of, if the degree of the top, if you're thinking like powers, and the degree of the top is bigger than the degree on the bottom, then there's no horizontal asymptote. If they're the same, then it's their leading coefficients in a fraction. If it's bigger, then it's zero, or the bottom is bigger than zero. The formal way to do that is actually to do a limit. So an actual horizontal asymptote is a limit as x approaches infinity or negative infinity of that function. Where's it headed? And so whatever it heads to, whether it be infinity, meaning there's not going to be one, whether it heads to a value, then it's exactly y equals that. Or if it goes to zero, then it's y equals zero. All right. Limits at infinity, if r being an exponent, is a rational number, meaning a fraction. It can be written as a fraction. Whole numbers count for that too. And just c is any value. Then these limits are going to approach zero because, again, if you remember what we talked about last section, if the bottom is so big, then the number is going to zero. That's all it's saying. So if the polynomial is focused on the bottom and the top is just a number like 2 over x squared, that's automatically going to be zero. And then if you do for exponential functions, same thing kind of goes because it's getting so big in some ways. It's hard to, it doesn't pinpoint a certain thing. If you look at that function, it's going to a certain value. Those will go to zero too. So those are kind of just like special things that you may want to know, especially this second one there. Okay. All right, so we're just going to practice all these things. All right, and so we're going to have the limit as x approaches infinity of 5 minus 2 over x squared. And so if I'm plugging in my numbers like we would regular, I'll have 5 minus 2 over infinity squared. And 5 is just 5, but we talked about before when I'm dividing by a giant number, which infinity is, so infinity squared is even more giant than it was. Dividing by a giant number makes it small, so it's going to go to 0. So I'm going to be left with just 5. Okay, so that's what we have there. The next one is we're going to do the 3. Well, if you recognize, let me just pull out that 3. You can pull out constants. That's e to the negative x. We'll look back. We already know that the limit as x approaches infinity of e to the negative x, which is here, we know that that is going to be 0. So I have 3 times 0, which is just 0. Okay. All right, the next one. So if you notice then, it's a little bit different. We can't do this the same way. I can't just plug in infinity. I'm going to have infinity over infinity. When you end up with something that's going to be infinity over infinity, you cannot do that. So what we're going to do is something called L'Hopital's rule. Well, we're doing a version of L'Hopital's rule. L'Hopital's rule is more later on, but it works out the same way. What we're going to do is we are going to rewrite our limit, but every single term in the limit is going to be divided by the greatest power of x in the denominator. So the greatest power of x in the denominator I have is x to the first power right there. So I'm going to divide everything by x to the first power. So I have 2 over x divided by x minus 1 over x divided by x divided by x plus 1 divided by x. Everything got divided by that biggest power of x in the denominator. And I'll simplify that. And you can end up where you skip some of these steps. You still need to show some level of work, but you can skip. So 2x divided by x is just 2. 1 over x stays 1 over x. X divided by x is just 1. And 1 over x stays 1 over x. When I go plug in infinity, okay, I'll have 2 minus 1 over infinity, and then 1 plus 1 over infinity. Now remember, dividing by infinity makes the number get tiny. So this is going to 0, and this is going to 0. So I'm left with 2 over 1, or just 2. Okay. Next one. Again, I can't just plug in infinity. Infinity divided by infinity is still a mystery. Even though that infinity square, we know it's bigger, it's still a mystery. So you still have to go through the process of doing that. So what we are going to do is we are going to divide. And until I actually plug in infinity, as I'll remind you, you have to write the limit. You can't not have the limit on there. It's your operation. So I'm going to do 2x. And when I divide it, if you notice, my biggest power of x in the denominator is x squared. So I'm going to divide everything by x squared. Every single term gets divided by x squared. And what I like to do from here, and I'll change colors kind of so you can see it, is I actually like to just go ahead and plug in here. And if that confuses you, you need to write it all out like we did in the previous problem, that's fine. But 2x over x squared is just 2 over x, which means I'm going to have infinity in the bottom. So the bottom is bigger. It's going to end up being a canceling. One of your x's out, but leaving some x in the denominator. It's going to go to 0. So that's going to go to 0. That's going to go to 0. That's just 3. And that's going to go to 0. So I'm left with 0 over 3, which is just 0. Go back to my purple. All right, so we're going to do a similar kind of thing here. We're going to rewrite this. 2x squared. But now I'm going to divide still by the biggest power of x in the denominator, but it's still x squared. So I'm going to divide that by x squared, 5 by x squared, 3x squared by x squared, plus 1 over x squared. And again, I'm going to simplify. So x squared over x squared just cancels, leaving that 2. 5 over x squared is 5 over infinity squared, so that's 0. 3x squared over x squared cancels just the x squared, leaving it just 3. And 1 over x squared, that doesn't look like an x squared, is 0 because 1 over infinity squared is 0, leaving me with just 2 over 3, which doesn't simplify. Okay. And then the last one. We're doing the same process. Biggest power of x in the denominator is x squared. So I'm going to rewrite this as the limit as x approaches infinity of 2x cubed over x squared plus 5 over x squared all over 3x squared over x squared plus 1 over x squared. So then these cancel, but I have x cubed on top and x squared on top, so it just cancels out one of those in all of the denominators. So it's just 2x on there. This goes to 0, this goes to 0, and this goes to 3. Okay, so if I'm plugging in infinity, I'm going to have the limit as x approaches infinity of 2x over 3. Okay, that's all that's left on there. And so then when I plug in infinity here, I get 2 times infinity over 3, and that's just infinity, okay? Because infinity divided by 3, well, that's nothing. It's still infinity. All right, we're going to find the limit here of each of these, okay? And we have the limit of sine x, and then we have the limit of sine x over x. We use something called squeeze theorem. Okay, go back to my purple. All right, so when I plug it in, if you picture, again, your graph of sine, if you remember your unit circle at 0, sine is 0, and at pi over 2, it's 1, and at pi, it's 0, and then it goes down -1, and you get this nice curvy shape here. So as x is approaching infinity, which means it's headed this way, what single value is it approaching? Well, it's not approaching a single value. It's going to 0 to 1 to 0 to -1 and going like this for ever, okay? Which means the limit does not exist because it's not approaching a single value at all, okay? All right, so then what happens when I just divide it by x is something super cool. Okay, I really like it. So the squeeze theorem is essentially saying that it's squeezing between certain values, so it has to be something. So for example, if I said, well, x is between 1 and 1, then what's x? It's 1. Okay, so that's what we're going to do, and that's what we're going to look at, is we're going to use a squeeze theorem for this. So what I want to do is kind of use the concept here. We knew this was between 1 and negative 1 sine x. So I'm just going to look at just that top part for now. Okay? So we know that sine x is somewhere in between 1 and negative 1. Well, just the function of sine x, we'll get rid of that. Is somewhere in between negative 1. At sometimes it's equal to 1, and at sometimes it's equal to negative 1. Just get rid of that. Okay, so that's true because sometimes it's equal. It's always in between it. It's never outside of that. All right, so then what I want to do is our goal is to end up making it look like what we have going on here, sine x over x. So I'm going to divide all parts by x. I'm keeping it balanced. Okay? And so that's an interesting concept because we know how to do certain limits. So if I actually take the limit of every part of this, so I'm just going to write limit as x approaches infinity of that whole thing. I can take the limit of just this side, negative 1 over infinity, and I'm going to get 0, right? And I can take the limit of just this side, and I'm going to get positive 1 over infinity, which is still just 0. But this whole time, sine x over x is still in between it. Therefore, we're squeezing it between 0 and 0, so the limit as x approaches infinity of sine x over x is equal to 0. So that's an interesting concept, the squeeze theorem. We might see the squeeze theorem one other time, but just show you some of the manipulations that you can do in problems. All right, find each limit. We're just going to start plugging in. So polynomials are cool. Even if there were other things, this is just x cubed by itself. But if I had x cubed plus x squared, basically, if you have more positive infinities than negative infinities, that's what it's going to be. If you have more negative infinities than positive infinities, that's what it's going to be for a polynomial, such as adding and subtracting, no dividing or multiplying. Well, you can multiply. All right, so this is infinity cubed, which is just infinity. This is negative infinity cubed, which is just infinity. Okay, keep in mind negative infinity squared, you would have to consider that to be positive. Okay, and then go ahead and if you look at this one, then we're going to, I left off the negative. This will be negative infinity. And then if we look at this one, we're going to break it down a little bit. So we can do what we did before, where we divided by the biggest power of x in the denominator, or we can do something different, which is a good review, is we can actually do the long division. Good review for this. So 2x squared minus 4x plus 0. Okay, if you're holding a place value, long division, and I have x plus 1. And you ask yourself, and this works for both c and d because they're using the same function, just one's going to positive infinity, one's going to negative infinity. And ask yourself what multiplies to x and adds to 2x squared. And so that would be just 2x. I'm putting it over my x place values. And I go ahead and distribute it. 2x times x, distribute it here. 2x times x is 2x squared. And 2x times 1 is just positive 2x. You need to subtract that whole thing. So I always say draw your line, change your signs. That simplifies. That gives us negative 6x. What can I multiply? You repeat the process. X to get negative 6x. Well, that would be negative 6. Then I go ahead and distribute that just like I did the other. I'm going to bring down my placeholder. Is negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Draw your line. Change your signs. And then I'm left with 6. And as a remainder, what you do is you write it as a fraction. So your remainder divided by what you were dividing by. And so I have this. So if I do that, I can go plug in infinity there and simplify. Well, if you notice, this guy is going to go to 0 because I have 6 over infinity plus 1, which is 6 divided by infinity, which is 0. And then I'm going to have 2 times infinity, which is just infinity, minus 6. Well, infinity minus 6, I don't care if you minus a million. Infinity minus a million is still infinity because it's it goes on forever. You can't ever stop it. So it doesn't even matter if you minus a million. All right. And so then I'm going to be left with positive infinity. We don't have to do the division again. We already did the division once. So I'm going to just go plug in negative infinity into the same thing. So this is still 0 because 6 divided by negative infinity, you can't have negative 0, it's just 0. And this is negative infinity. 2 times negative infinity is still negative infinity. And so minus 6, again, doesn't change it, plus 0, and so we just get negative infinity. Same type of thing would happen if you would have done the divide everything by x and then plug it in. You would have gotten something similar. Just have to be careful with the negative infinities are where sometimes it can get tricky. Okay, so that is the end of notes. Make sure you're working on. I hope the survey was a little bit enlightening. In some of the options I put at the end, that some of you really did think of a lot of ways to get help and be successful. Some of you need to probably use some of those things on that list so that you can be more successful. There's a lot of resources out there for you, and there's only about a month left until I come back, and you guys are handling things overall really well. One thing I noticed, you guys need to read directions a little bit better, and I think it would make a big difference. I know it's hard to learn virtually, but it wouldn't be that much different if we were in person because we wouldn't have the class time, so we'd still have to supplement out here. It's AP. We can't slow down. We're already going slow enough as it is. Typically, I would be done with chapter 2 by now. And so we have taken a little bit slower because of the remote scale of it. Your test next week, I'm going to be looking at, it'll still be online. You'll still have all day to do it. We'll do it Friday on your remote day. And you'll have from 8 to 3 to take it. And it will be a standard piece of paper test, but you'll have to fill it out in Cami. But it won't have to switch back and forth. So it's just your work. If you want to type, you can type in Cami. So if some of you have terrible handwriting and certain things you want to write or type, that's fine. But a lot of the math will need to be written out. Okay. So I just need to see that. If you need to attach extra papers to it, you can. Okay. That's not a problem to me at all. Just make sure you ask questions. My goal is to have an actual practice for you. We'll just see how that goes, hopefully by Monday. And so that would be a homework assignment. That would be for a small grade. All right, I'm going to get off here. Hope you guys have a good rest of your week. Please make sure you're keeping up with things. I will not be taking homework past next Friday. So if you're missing any homeworks, you need to get that in. The end of the quarter is next week. All right, have a good week.